I think a very helpful tip for those preparing for Oxbridge interviews is to have an academic partner whom they can discuss maths or any other topic really, and they can do mock interviews with each other. So I have been doing a lot of lemma questions with my friend, and one of the questions he asked me in the most recent mock interview we had between each other was this question. And I've been preparing for number theory a lot. Um, so I will be doing this question. So, sorry, I already know how to do it. And I'll walk through my solution. Now, the question is as follows. Find 3x squared y squared if x and y are integers such that y squared plus 3x squared y squared is equal to 30x squared plus 517. The first thing I said actually was that 517 is quite an interesting number, and I will get to why I said that after. Now, here there are multiple ways to approach this question. The first thing I did is to bring everything to one side because I wanted clarity. I wanted to see what's going on. So I'm going to bring everything to one side, and then I realized that this is actually something I can factorize in some sort. Well, at least I can make something the subject, and I decided to make y the subject. Um, if I do make y the subject, I get something of the sort. And I think at this point is where I realized actually I didn't have to bring everything to one side. I just did it for the sake of it. Um, oops, that's not meant to be there. But yeah. Um, and then what I did is to rearrange for y squared. Now, before I made any other observations, I realized that 1 plus 3x squared is quite a convenient number to have. Because 30x squared and 3x squared, the only difference between them is that 3 times 10 is 30. So perhaps I could manipulate this in some way, and I decided to rewrite my numerator as follows. And this is why the most acute-eyed amongst this audience may realize what I have just done and why it's a very, very cool thing I did. Because now I can simplify my fraction, my very ugly fraction. I'm having problems with my writing pad, and my OneNote is about to crash once again. It's fine. I hope it doesn't happen in my actual interview. Moving on. This becomes 10 plus 507 over 3x squared plus 1. Okay, now I can make a few observations. Y squared is an integer, and it's a perfect square. Okay, that's very important. This implies that if my left-hand side is all of these things, then my right-hand side must also be an integer and a perfect square. And if we read the question, the reason I'm saying this is an integer because it's specified in the question itself. I don't know why it's not showing me the question. Why is it blank? Hello? Okay, there you go. If 3x squared y squared, find 3x squared y squared if x and y are integers. So if y is an integer, then y squared must also be an integer. So this means that if when we know 10 is an integer, um, then 507 over 3x squared plus 1 is not necessarily an integer, but we know it must be an integer. So we need to find all the cases where this is an integer. And to do that, we need to explore the number 507 and break it down into its prime factors. Um, my friend noticed that when he did the question, it took him some time to realize that 507 you needed to find the prime factorization of 507, and I think that's completely understandable. That's not an obvious step for a lot of people who haven't seen a lot of number theory questions, or in the middle of interview pressure it might be the case that you forget. But yeah, 507, I mean the digits add up to 12, therefore multiple of 3, so it must be divisible by 3. That is 1, 2, 20 divided by 3 is 6, 7. That was not on purpose. I promise that was not on purpose. That 6, 7 was not on purpose. Oh, we have a 6, 9 as well. Nice. So 507 is divisible by 3 and 169, and therefore 169 is divisible by 13. It's actually 13 squared. So we have the following. So all the factors of 507, all factors of 507 are 1, 3, 13, 3 times 13, which is 39, 3 times 13 times 13, so 169 times 2, which is 507. I think I'm missing one other. Am I missing one other one? 39. No, I'm not missing any other one. I think. Yeah, I'm not missing any other factor. It's fine. Um, so now I want to check everything what x is, where we know that x is a 3x squared plus 1. I mean, the denominator, 3x squared plus 1, yes. What is x if x is 3x squared plus, sorry, what is x if my factor is in the form of 3x squared plus 1, okay? If it is 1, if 3x squared plus 1 is equal to 1, then x is equal to 0. Okay, if 3x squared plus 1 is equal to 3, then I have x is equal to, well, this x squared is equal to 2 over 3. And now we know that x must also be an integer, so we can reject uh, my x being 3. What about 13? 3x squared plus 1 is equal to 13. X squared is equal to 4. Okay, that's quite promising. Therefore, x is equal to plus minus 2. Okay, 2 is an integer and minus 2 is an integer. That's fine. What about 39? 3x squared plus 1 is equal to 39. 38 over 3, that's not divisible. So x is not an integer. So we can reject this as well. 3x squared plus 1 is equal to 507. 508 is not divisible by 3. Therefore, x is also not an integer here. Notice I'm being very systematic. I have this table here to make sure my work is neat, although it's clearly not that neat. But yeah, so my candidates for x are 0, 2, and minus 2. Now I'm going to rewrite my expression I have for y squared. Y squared is equal to 10 plus 507 over 3x squared plus 1. Now bear in mind, if x, I'm going to call this actually, I'm going to call this f of x. If f of x, f of 0, is not a square number, then I can reject 0 as my solution, because y squared must be a perfect square and an integer. And that is 517, so we can reject 0 as my candidate for x. Now, because x squared is an even function, so f of minus 2 is the same of f of 2, Therefore, it doesn't matter what I put in. 2 squared is 4, 4 times 3 is 12, 12 plus 1 is 13, 507 divided by 13 is 39, 39 plus 10 is 49, and 49 is equal to 7 squared, therefore it works. So, this actually works because 49 is a perfect square and it's an integer. So we've found our y squared. So now we need to find 3x squared y squared. I know x squared is 4, y squared is 49, so 3 times 4 times 49, which is 12 times 49, which is 490 plus 98, which is 588. And that should be my solution, or at least my 3x squared y squared. And I think this is a wonderful question because, I mean, this is from IME, the American something. Don't actually remember the name, the actual acronym, and it's on Lemma, so you guys can go and have a try yourself. I think this question is very cool because it's it, you have to work case by case, and if you're not systematic with your work, like this table, I think is what saved me the first time I did it. Actually, the first time I did it was much neater. Um, then you're gonna struggle working through this question. I think I really enjoy this question because it's, I mean, none of the maths here is complicated. That's the thing. It's all trivial things. But yeah. Um. Okay, I can stop recording, I think. Bye.